Ever wondered why your AI assistant sometimes sounds like it's stuck on repeat? Like it's so smart, but it just can't stop itself from echoing the same phrases. Well, scientists are cracking the code on this, and it's all about the hidden neurons inside these models. Let's break it down. At their core, AI models like GPT or LLaMA are trained on vast datasets of text. They function by predicting the next word in a sentence, learning patterns from trillions of examples. But here's the catch. When they encounter repetitive structures, like a phrase that repeats over and over, they start mimicking that. It's like a student who's so focused on copying examples that they forget to think for themselves. Now here's where it gets fascinating. Researchers have identified two critical components: repetition neurons and induction heads. Repetition neurons act like the model's repetition detectors. They fire up when they spot a pattern. Induction heads, on the other hand, are part of the attention mechanism. They act as pattern switches, directing the model's focus to words that match what it's about to generate. Together, they create a feedback loop that can lead to repetitive outputs. But how did they find these? The team ran an experiment. They created 1,000 texts filled with repetitive phrases and fed them to the model. By analyzing how the model reacted, they pinpointed which neurons were most active. Then they did something clever. They ablated, or disabled these neurons in different layers of the model, like testing different parts of a factory assembly line. Here's what they discovered. Early layers, disabling repetition neurons had almost no effect. Middle layers, it cut down repetition by up to 40% without harming the model's ability to learn from examples. Late layers, messing with them broke the model's pattern recognition entirely. It's like removing the engine of a car. No power, no progress. But here's the kicker. Induction heads had a bigger impact on pattern recognition than repetition neurons. However, when both were disabled together, the model's performance tanked. It's like a chain reaction. Induction heads spot the pattern, then repetition neurons repeat it. If you break the chain, the whole system falters. So what does this mean? It shows that repetition isn't just a glitch. It's a key part of how models process information. By understanding these mechanisms, scientists can fine-tune AI to avoid unnecessary repetition while keeping their learning superpowers intact. It's like giving the model a better editor, cleaning up the noise without losing the message. Take LLaMA 318B, for example. When researchers removed specific neurons and induction heads, some models crashed hard, while others adapted like a team recalibrating tools. This highlights that even similar AIs have unique workflows, much like factories solving the same problem with different strategies. Why does this matter? Imagine managing a factory. If you know which workers are crucial for quality control, you can streamline the team without messing up the product. Same with AI. Figuring out which parts are essential lets scientists build smarter, faster systems. Next time you see an AI writing a story or solving a problem, remember, it's not magic. It's millions of tiny, specialized workers collaborating. And now you're in on the secret of how they do it. What do you think AI will learn next? Drop your ideas below. Let's geek out together.